Hello everyone, this video discusses question 3 of the Mathematics of Mechanics paper 2022 by the SQA. As we can see, question 3 presents us with a projectile question. A ball is kicked from horizontal ground with a speed of 25 meters per second at an angle of 30 degrees to the horizontal. A. Calculate the maximum height of the ball. Now I would call that the maximum vertical displacement. As the ball falls, it is caught at a height of 1 meter from the ground. Calculate the total horizontal displacement of the ball during its motion. Well, this is a motion question, so the first thing we do is consider the equations of motion, and here they are here. Now these are the 4 equations of motion for a constant acceleration in 1 dimension. Except we're not working in 1 dimension, now we're working in 2 dimensions, because remember, as a projectile travels horizontally, it's also travelling vertically. So a projectile will span 2 dimensions. So how do we use equations that are written for 1 dimension to be used in a 2-dimensional problem? Well, it's very, very simple really, because the 2 dimensions can be taken separately. So when the ball is going horizontally, that's completely independent from the fact that it's also rising or falling vertically. So we write our equations to suit. And here you can see our equations of motion written for vertical motion and horizontal motion. And the subscripts never appear in the same formula, and that's very, very important. However, we can make a very important simplification here when it comes to the horizontal motion. There is no horizontal acceleration when it comes to projectile motions, because when the projectile has been launched, there's nothing pushing it horizontally and there's nothing pulling on it horizontally. So its horizontal acceleration is equal to 0. Now if we rewrite our equation of motion for horizontal motion, including the fact that horizontal acceleration is equal to 0, we get 2 simple statements of fact. UH is equal to VH. That's simply telling us that the horizontal velocity is the same for the whole flight. SH is equal to UH times T. Well, that's like distance is equal to speed times time. The first question asks us to find the maximum height reached by the ball. Well, we have to remember at its maximum height, its vertical velocity is equal to 0 because it's not rising or falling. So the problem reduces to this. At what height does the ball reach when its vertical velocity is equal to 0? Well, that's at its highest point. So if we can solve that question, we've got the answer. Now, we use the formula v squared is equal to u squared plus 2as for vertical motion. So we only put in vertical information in that formula. Now v squared, the final velocity, or the velocity at its highest point, is equal to 0. Now we use squared as its initial vertical velocity, and that is the vertical component of the 25 meters per second vector at an angle of 30 degrees to the horizontal, which of course is 25 sine 30, 12.5. Put all the values in and we get an answer of 7.93 meter per second, the maximum height the ball reaches. So the next question is, well, we're told the ball is flying through the air and it's caught at a height of 1 meter from the ground, and we wish to know the horizontal distance travelled during that time. Well, the horizontal distance travelled is given by the simple formula. Horizontal distance is equal to initial horizontal velocity, which stays the same, multiplied by the time. And it's the time it took the ball to reach a vertical displacement of 1 meter on the way down. Now to use that, to find that time, we use s equal to ut plus 1/2 at squared for vertical motion. So we can only put vertical values in that formula. And when we do that, and remember that the vertical displacement we're looking for is 1 metre on the way down. We end up with a quadratic equation that we have to find the roots for, or in other words, the values of t that satisfy that formula. There is our formula for t that we should all be familiar with. In our case, a is equal to negative 4.9, b is equal to 12.5, and c is equal to negative 1, as you can see. Now when we put the values in, we get two answers for time, 0.08 seconds and 2.47 seconds. We take the larger time because that's the time it took the ball to reach a height of 1 metre on the way down. Now we have to multiply this 2.47 seconds with the horizontal velocity. And the horizontal velocity can be found out from our initial condition, which is the horizontal component of the 25 metre per second vector, which is 25 times the cosine of 30. Multiply that by 2.47 seconds and we get an answer of 53.4 metres. That's the horizontal distance the ball covered, or its horizontal displacement, when the ball reached a height of 1 metre on the way down. Now there was a jolly good question there on projectile motion. The next question deals with simple harmonic motion, and I'll put together a video on that shortly. Thanks for watching the Scottish Physicist.